Hello, how are you? Now this is third video on calculus. I have separated all these concepts in different videos for calculus. In first two videos, what we have seen, we will recap in 1 minute. In first part, we have seen these two terms which are important for calculus. Actually, we have seen that what is mathematics, what is algebra, geometry, okay, but these are two important terms for calculus. From that part, means part 1, from that video, what is the actual conclusion for this word, for this term? Infinitesimal tends to 0, means very small, you can't imagine. This infinitesimal converts algebra into calculus. What is continuity? It is continuous, something continuous change because of other changes. This change because of that change, that is continuous change, not jumping change. We have seen jumping change also in first video of calculus. Okay. Continuity express need of calculus. Means if there is no continuity, if there is jumping, there is no need of calculus, algebra is sufficient. We have seen in first part. In second part, we have seen these two important terms which are required for calculus. Limit. It gives tool to reach infinitesimal. We have seen that limiting process for differentiation and for integration for both. And function gives way of change of dependent variable, that is our y, generally y. Dependent variable changes because of x change, means y depends on x, that is function. These are four important terms. You can see that is the foundation of calculus. And when this process started of calculus, because of differentiation it started, or because of integration it started, which is the first, differentiation or integration? Before 2300 years, okay, 2300 years, Archimedes got problem, and that problem is measurement of area of curve sides, means because of curve, that is the problem of measurement of area. You can say circle. Means it started with integration and not with derivative. That's why we are entering for integration in this video. All these terms gives, this is the conclusion for differentiation, this is the conclusion of integration. What is the conclusion? See, slope of graph gives differentiation. That slope of tangent, from slope of tangent we get differentiation. Tangent is actually Latin word, it is called, actually it means touch. That's why we can say that curve having one line which is touch in only one point, that is tangent, we have seen. Okay, means slope of tangent when limit dx tends to 0, when dx becomes very small, infinitesimal small. You can see it is tan theta, slope is tan theta, we have seen. And last, area under graph, total area under graph, that is the summation, that is integration, that is addition of all small areas, gives integration. Which small area? From area of rectangle, when limit dx tends to 0. After this, we will see actual integration process, means how we develop formula for integration. Simple formula, you know the formula, you know the result. Now we will learn how the process is developed to reach the formula, any formula. Okay, here I have taken two examples. I have drawn one graph, PQ is graph, In this case, PQ is graph. In this case, this graph having one equation. Every graph having equation if it is continuous. This is continuous graph, straight line. It is also straight line having some slope. Now, what will be the equation for this graph? This is value 8, and this 8 is not changing, means y is not changing whatever the value of x you have taken. Means y does not depend on x, y has its fixed value. That's why you can write y is equal to 8. This is the equation of this straight line, this is the equation of this graph. Then what should be written in this case? Is y is equal to f of what? Function of what? It does not depend on x, it does not depend on z, means it does not depend on anything. Means it doesn't depend, means there is no dependent, means this is not dependent. Then what should be written here? Nothing. It does not depend, it depends on nothing. Nothing means 0, means y is function of 0, because y is now independent, does not depend. In this case, value of x increases, value of y increases, you can observe. But as it goes to 10, it goes to 10, and it is straight line, means value of x and value of y are same. That's why you can say y is equal to x. This is the equation of this graph, yellow color graph. Means y is function of x. In this case, you can write here x, because as x increases, y increases. What is the function? This is the function. Y is, here there is no square, there is no cube, not root. It is power of 1 of x. This is the function. Now I want to find out area under graph, area under graph PQ. How to calculate? From simple geometry, length into breadth. Length is 10, breadth is 8 into 8, means 80, whatever the unit. Okay. In this case, you can calculate by formula you know very well, because it is triangle, this area of triangle. What is the formula? Half into base into height. Base is 10 and height is 10. It is 50. Clear? This area is very simple to find out by using algebra, by using geometry. No necessity, no requirement of calculus. But if we have to find out this area and this area by calculus, suppose I don't know the formula for this triangle, I don't know this formula, then what to do? Then you can use calculus and you can develop the formula of area of triangle. You can discover the formula. See, means this is algebra, this is geometry. Now you have to apply that concept, calculus here. I am applying calculus here. This is algebra. Now this is infinitesimal algebra, that is called calculus. How? You have to convert this area into small slices. We have seen in second video. Okay. Now this length is very small, that is infinitesimal small, but it is not 0. Means how many slices we can make, I don't know, but not infinity. If infinite slices are made, then you can say that dx will be 0. That is different thing. Means you can't divide any quantity by 0. That is indeterminate. That is different thing. That's why these slices are not infinity, but it is tending to infinity. Just like tending to 0, that is infinitesimal, same. Now this dx is the small width of this rectangle, the small rectangle, okay, and this is the corresponding y. I don't know corresponding y. Suppose this is length and this is height, then you can say this y is nothing but h, you can take, and this is length, then dx can be acted as length or base. Okay, now this rectangle having area of small rectangle is equal to this length, or you can say breadth, and this length, this h into dx, or this y into dx, any form you can take, h into dx. Now this h, or you can say y, anything, because we want only area of small rectangle, but we have taken y as dependent, means this h or y is dependent. Symbol you can take y or h, there is no make difference. Then y is equal to x, then you can put here x, remember, because its equation is y is equal to x, you can replace the value, means it will become x into dx. See, x into dx, means this is the area of small rectangle. How many rectangles are there? I don't know. You have to add all area, means area of all rectangles you have to add. That is summation, that is addition, that is integration. But summation having symbol like this one, this is symbol of summation generally, and this is symbol of integration. What is the difference? Both are addition, but this summation is used, that is the, now you can see it is convention. This summation is used if you know the numbers. How many rectangles are there? 1 crore, you can take this one. 10,000 crore, you can take this one. If you don't know the number, take this one. If it is continuous, if it is infinitely small, that's why you can use this one, but you must know the how many rectangles there in number, how many. If you don't know, forget it, don't use this. Now integration of what? Addition of what? Area of all rectangles. This area is small area, that's why it is represented as dA. It is not because of small it is taken d, it is difference of something, means from this point to this point, this is suppose x2, and from this point to this point, suppose this is x1, then there is difference, x2 minus x1, that is dx, means this total area minus this small area. There are two triangles, from this 0 to this point, suppose you can say it is S, from 0 to this point, suppose it is T, OS and this point S dash, OT this point T dash, means there are two triangles. Now this area slightly large triangle and this area slightly small than that large, that difference is dA, means D is not representing small. I have explained in second video, D is not small, D is difference in area. Difference in area is small, that I accept, no problem. Okay. Now integration of all area means addition of all area is equal to integration of x dx. This is total area under this graph. Now how to calculate this one? There is a simple formula, x raised to 1 here. Now development of that formula is different thing, but I am giving one example of integration. Formula is x square by 2, because general formula is integration of x raised to n. How to say, how to how to write is simple, but some students say integration of x raised to n into dx. Some students say integration of x raised to n with respect to dx. No problem. And its answer is x raised to n plus 1. By using this formula, you can write here x raised to 2 upon 2. This is the formula. Now, what is the difference between this formula and this formula? This is half base into height. This is also half base into height, because in this case base is x and height is also x, because y is equal to x. Y is equal to x. Then you can write half x into x means half y into x means half base into height. That is the formula of triangle. We know from 6th standard, 7th standard. This is the application of integration. Now, problem is, if this formula is available, then why to use this formula, this method? No, it is not necessary to use this formula. I have given one example how to develop the formula of area of triangle. But if this graph is not straight line, then there will be problem, and we have to develop that formula by using integration. We have to obtain area under that graph, which is very complicated for algebra, for geometry, but it is very simple for calculus. In this case, you can say area under graph. It is triangle, na? Simple triangle, but we have taken rectangle. Can we convert this triangle into rectangle for same area? In this case, area is 50, 10 square, 100 upon 2, 50. This 10 is fixed, no problem. Then 10 into what? We will get 50. 10 into 5 means this rectangle can be converted into triangle. This will be triangle. This will be rectangle. This triangle can be converted into rectangle having 10 as x and this y as 5. Means you can say any area can be converted into rectangle by using integration. This is the core of integration. Any area is converted into rectangle. Any area, circle, triangle, any shape should be converted into rectangle. That is the result of integration. Okay. Here I have taken two examples. This is one simple graph, PQ graph, having this equation, y is equal to x square. Means y is function of x. What is function? Function is squaring. Square is function. I want area under this graph. Now it is impossible to develop that exact rectangle because it is curve, not straight line. Just like our straight line that just we have seen. Means in that case also there is problem. In this case there is also problem. But now what we have to do? How to find out area? Calculating very small area, infinitesimal small area. That area is y into dx. Only one. And integrate it means add all such areas. But you have to put the value of y as x square. Means this x square into dx, this is nothing but the area of rectangle, very small rectangle. You can say this is the rectangle. Now you have to add all such areas from 0 to this point. Finish. That is the answer of total area. How? We have seen the formula. If x raised to n is there, then formula is x raised to n plus 1 upon n plus 1. Here x is raised to 2. Then answer will be x raised to 3 upon 3. This is the answer. But I want range from 0 to 3 up to this point. I want area. Then you can write limit is 0 to 3 for x 0 to 3. This 0 to 3 limit is written, this is tradition, outside of this bracket, rectangular bracket, from 0 to 3. This is the method. Don't worry, don't get botheration about this method. Okay. Now you can put the value of x as 3 as 0. Means you have to put the values of x from top, from bottom, like this one. 3 raised to 3. This 3 as it is. Again 0 raised to 3. This 3 as it is. And you have to subtract it. Whatever the range. Suppose you have taken from this point. Suppose this is a S point. SQ. Under graph SQ I want area. Then you have to put 1 instead of 0 here. Put 1 here. Put 1 here. Put 1 here. Finish. You will get this much of area. From 1 to 3. This much area you will get. Now here answer is only 9 by 3. 3 into 3 means 3 cube, 27. 27 by 3 means 9. Total area under this graph is 9. You might have understood this. Okay, means we can find out area. How can we convert this area into rectangle? We will convert. This is rectangle having base 3. Base is 3. What should be the width? Width should be 3. You can calculate from this one. Means actually it is going here. Top point is 9. But if it is converted to rectangle, then it is actually not forming rectangle, it is forming square. It is forming square. Now I have taken one more example. This is interesting example. Why it is interesting? Because we know actual formula of area of circle, pi r square, if r is radius, and we know the formula of perimeter. But from perimeter, can we derive the formula of area without calculus? We will try, okay, without calculus, by using algebra, by using simple geometry. I have cut this circle into 4 parts. I have given color for simplicity. Okay, and these 4 parts arranged like this one. You can observe. Now total perimeter, total length of the circumference is 2 pi r. Means this part from this part to this part, this is 1/4 of 2 pi r. Means it is pi r by 2. This is pi r by 2. Pi r by 2. And radius is r. But it is curve. Means you can't say it is triangle. Then increase the triangles. Make different sections. Again it will become 8 parts. It will look like this one. Then this pi r by 2 again get decreased. It will become pi r by 4. And this process of decreasing, cutting, is continuous up to tends to infinity. That's why this area will become infinitesimal small. But this is not possible for me for the chalk. I have developed only 8. Now this total length is 2 pi r because the circumference is, this is circumference. But this arc and this arc having slight difference. This is more arc. This is somewhat less arc, you can say. If you are increasing that triangle, then this arc will look like straight line. One simple question for you, I generally ask. This chalk is actually cylinder, but this is line which is straight. You accept. Your mobile, it is just like rectangle. It's one part, one edge is exact straight line. Your tube light is exact straight line. We say it is straight line. You say, your parents say, your friends say, my friends say, everyone say this is straight line. this blackboard having straight edges? We say, but remember, there is no straight line in this universe, though there is a chapter straight line in mathematics. Remember, there is no straight line, means there is no absolute straight line, because we feel our floors, our tiles are plain, because we feel their edges are straight. Why? Because it is very, very small. Actually, it is a part of earth, and earth is not plane, earth is sphere, means our tile is a part of that sphere, but we seem it is straight, it is plane. Actually, it is not plane. That's why you can say that straight line or that curve, similar. That is the answer for this one. If you are increasing and if you are tending to infinity or infinity triangles, means you are decreasing this arc infinitesimal small. That's why you can say that arc is not arc, it is straight line. And if it is straight line, then total length is 2 pi r, no problem. And this oblique will become vertical if it is very, very small. You can imagine, you can visualize. Then it will become a rectangle. It is not rectangle, but you are increasing the triangles, then this gap will decrease, and finally there will be no gap. Then you can say it will be rectangle. And what is the formula of rectangle? Length into breadth. What is length? In this case, it is 2 pi r. It is seeming 2 pi r. But I have taken triangle. For triangle, you can say area of first triangle is equal to area of first triangle. I have not taken rectangle. I have taken triangle. Area of rectangle is half into base into height. This is base and this is height. I mean, this is not correct, but this is approximation. Then this is one area. How many areas are there? Are 8. No? The total area of 8 triangle will be 8 into this area. Then you can get pi r square. That is the area of circle. This is way to visualize integration. Means if you are increasing this triangle, means you are getting calculus, you are getting integration. Simple. I will take one more example, and that example will be clearly understood. Why? Because you know all formulae. Regarding that concept, I am taking example. Okay. I have taken 3 concepts: perimeter of circle, area of circle, and volume of sphere. We have to derive the formulae. Don't learn formula, learn by heart, memorizing. That is essential, but only learning, memorizing is not mathematics. Now we will develop the formula perimeter. We will develop the formula pi r square. This is the area of circle. See, this is the basic formula of angle. Angle is equal to arc upon radius. In this case, I have taken small angle. Now you know what is small. Infinitesimal small. D theta is infinitesimal small angle. Therefore, this arc is also infinitesimal small arc upon radius. I want perimeter, circumference. Means I want to add all such dx's, all dx. You have to add. Means you have to integration of dx. Then you will get total length of perimeter. That's why you have to develop the formula of dx first by shifting this r. Then you will get formula of dx. Dx is equal to r into d theta, cross multiplication. Then add all dx, means integrate dx. Means total length will be integration of dx. means integration of r d theta. This is the perimeter. But in this case r is constant and we are changing d theta, means you are adding only d theta corresponding dx. R is constant, then you can write r is radius, but you are adding d thetas only. You are adding d thetas, not r. Now this total d thetas after addition of all d thetas will be total angle of the circle. It is complete circle, and you know very well it is 360 degree. But generally it is written in SI form. It is radian, means total angle will be, actually you directly write total angle, or you can solve by simple, by rule. Rule is rule. What is rule? What is the derivative of d theta? Integration of d theta? It is theta. Why? Because addition of all d thetas is total theta, and total theta for one complete circle is nothing but 0 to 2 pi radian, and we know that. That's why you can write 0 to 2 pi here. This is perimeter, this is circumference. Now put the value. Now we know the rule. Put the top value, put the bottom value, and take subtraction. Means answer will be r 2 pi minus 0, means 2 pi. 2 pi r is the perimeter formula. By using this formula we can obtain area. Just now we have seen that triangle, number of triangles. In this case I have taken small ring having small width. Small means infinitesimal small. I want total area of circle. If you know this formula of perimeter, you can find out, you can determine the formula of area of circle. How? We will see. Now area of this small perimeter, this red color, area of perimeter, or you can say area of ring, not perimeter, area of ring, not perimeter. Area of ring is equal to, now radius of that ring is smaller, and radius of this circle that I want the area, that is capital R. Now what will be the circumference of this small ring? This is the formula. Means circumference will be 2 pi r. This is circumference. And what is the width? I have taken dr. Dr is the width. Why it is dr? Difference. Difference of what? This is inner circle and this is external circle, outer circle, slightly outer. It having small radius, small higher radius, means more than r. It will be r dash. Means this dr nothing but the r dash minus r. It is very, very small, infinitesimal small. Now suppose, now you have to imagine, cut this ring in mind and make it straight. It will look like rectangle, very small rectangle. What is the formula of area of rectangle? Length into breadth. What will be the length? Suppose it is straightened. What will be length? Length is nothing but the circumference. This is the length. And what will be the width? Width is dr. I have taken. Means 2 pi r into dr. This is the formula of area of very small ring. Very small ring. I want total area of circle. Then what to do? Now you have to adjust one more ring having slightly higher radius, greater radius than r dash. That will be another ring. Put another ring, put another ring, put another ring, means number of rings. Infinity? No, tends to infinity. Again put smaller ring, smaller ring, smaller ring, smaller ring, smaller ring. Infinity? No, tends to infinity. Means there are number of rings having formula of area as 2 pi r into dr. But every time r is changing. That is the problem. That problem can be solved by integration. Means total area will be total area of all small rings is integration of this, addition of all areas, small areas, addition of 2 pi r dr. This is area of small ring. This is symbol of addition, addition of all small rings. Solve this one. Last ring is this ring and this ring. This center ring having radius 0, it will become point, and outermost ring will have radius capital R. This will be the range. You have to put here range 0 to capital R. Then area will be, this 2 is constant, this pi is constant, take outside, it will become 2 pi r. And integration of r with respect to r, then we get area is equal to 2 pi, from 0 to r we can put here 2 pi. What is the integration of r with respect to r? We have seen it will be r raised to 1, means r square by 2. This is the formula, r square by 2, because this is 1. You can treat as n, r raised to n, means integration of r raised to n with respect to r is r raised to n plus 1 upon n plus 1. Here n is 1, means 1 plus 1 is 2, from 0 to r. 2 gets cancelled. Then a is equal to pi, put the value of small r as capital R, top value, rule, bottom value 0, forget it, top value is r, means r square, pi r square. Formula area of circle by integration method. By same way we can find out the volume of sphere. Again you have to imagine something small. In this case something small is surface area of small sphere, and you have to increase that small sphere. Suppose this is small sphere and slightly larger sphere. Both are having different surface area, but we have to treat surface area as 4 pi r square, because the distance is infinitesimal small. But this surface area means surface into width, that will the volume of this hollow sphere, yellow color hollow sphere, means yellow color having volume as 4 pi r square into this width dr. This is the volume of small hollow sphere. Now you have to put one more small sphere, hollow sphere, again small hollow sphere, again small, means you have to fill it up. Again fill it up by decreasing. Then total will be yellow color. That is total volume. Then total, this is for hollow sphere. I want total volume of sphere, means again you have to add, integration of this small, integration of 4 pi r square dr. What is the range? From 0, because first one will be having 0 radius and last one having r radius, capital R. This is range 0 to r. Then v is equal to, take 4 pi outside because it is constant, 4 is constant, pi is constant, both are constant. The integration of r square with respect to r, again formula. Now treat that 2 as n, means r raised to n plus 1, means r raised to 2 plus 1, r raised to 3, r raised to 3 upon 3, from 0 to r. Take 3 outside, it is constant, means v is equal to 4 by 3 pi, put small r as top value, top is r, bottom 0, forget it, it will be r cube, volume of sphere. This is the application of integration. I have shown only about area, circumference, volume, but there are number of applications. Example, suppose you are filling your water tank by putting 10 liter in 1 minute, 10 liter in 1 minute, 10 liter in 1 minute. Means after 60 minutes it will be 600 liter. But suppose I want to ask after 30 minutes total volume of that tank, means the total volume of water will be 300 liter. But between 29 minutes and 30 minutes it will be 290 liters. But suppose there is a cork, and that through cork suppose continuous water is flowing and it is filling the tank continue, and its rate is same, means in 60 minutes it is filling 600 liter. Then you can find out between 29 and 60 minutes, 29 and 30 minutes, it will be not 290, it is continuously increasing. At any time you can find out the volume, at any time. Means after 29 minutes and 5 seconds, what will be the volume of that water, you can find out, because it is continuous process. At that time you have to apply integration. Otherwise you are filling with that vessel badli, then it will be useful for you can apply only algebra, simple algebra, this into this. For continuity, integration is must. And remember, integration and differentiation are opposite, I have explained. Like suppose x is given to you, I will say square it, then you will say x square. Then what will be opposite? I want again x, then you will say it is square root. Yes, squaring is forward, then you can say square root is opposite. If I have given x and I want square root, then you will say root x. Again I want x, my x, then you will say square it. Means in this case square root is forward and squaring is backward. Means which is forward, which is backward, that is not important. Both are opposite to each other. But generally differentiation is started first and then integration is taken. It doesn't mean that differentiation must be first. Both are opposite. Take logarithm, take anti-logarithm, take cube root, anyone. Okay, addition, subtraction, multiplication, division are opposite. Suppose I given 100, multiply by 5, it will be 500. I want again my 100, then you have to divide by 5, again I will get 100. Means multiplying and division are opposite process, like this one. Differentiation and integration are opposite. After this video we will see differentiation. Differentiation means derivative of sin x is cos x. In this case we can say integration of cos x is sin x. But how it converts into sin x, how it converts into cos x, where that sin is gone? It vanishes. We will see. And one more thing, after that video there will be no videos on mathematics, only videos on physics. Now you can enjoy, because after this differentiation will be there, simple differentiation. Okay, then enjoy and take care. Bye.